Okay, well, let's solve some exponential equations. First, we're going to recall something. So the strategy that we're going to use at first is going to depend on what one-to-one means. So we're going to solve exponential equations. So recall what that means. So one-to-one, this meant that there's a one-to-one correspondence between inputs and outputs for the function, right? So any two outputs from the function that are the same have to have the same input. So with math stuff, we write this like this. So if I've got two function values that are the same, if f of x equals f of y, so if f of x equals f of y, then we have to have that their inputs were equal, right? If I've got two functions that have the same output, then that means that input had to be the same. So when we were first talking about exponential functions, one of the properties of exponential functions was that they were one-to-one, right? Remember when we were drawing the graphs, they either looked like this or like this, just the basic one, right? So all of these things pass that horizontal line test, right? If I've got two function values that are equal, then their inputs have to be equal. Well, there aren't any function values that are equal here, right? It's all smooth and continuous. This one's always increasing, so we don't have any equal function values. This one's always decreasing, right? So none of the function values were going to be equal there. So if I've got two outputs that are the same, then the two inputs have to be the same because it's one-to-one. Well, very specifically, we can phrase this with exponentials, right? If a to the x equals a to the y, then x is equal to y. So what this is saying is that if we can rewrite both sides with the same base of an equation, then that means the exponents have to be equal. So this says more or less giving us a roadmap of what to do. So we're going to rewrite equation with the same base on each side. Okay, so we can do that. We've got a strategy here, and we can get rolling. All right, we've got a couple of nice exponential equations here. Let's knock this one out. So we want to solve these, right? And we're going to try to write these with the same base, right? So 3, that's probably going to be your best bet to write as a base here. I mean, we can look at these all at the same time, right? So numerically, we want to be looking to see if they share a common base. So think about the easy thing, you know, the air quotes easy thing, right? So that'd probably be a 3. Can I write 27 as a power of 3? Well, yeah, we can. We know that 3 times 3 is 9 times 3 is 27, so we can rewrite this one as 3 to the third, right? So I've got 3 to the x minus 1 equals 3 to the third. Okay, and you know, I said we're going to look at all these, right? So this one we'd probably look at the 5, and we want to write this with a power of 5. This one down here, we're probably going to want to write everything with 3s, but we can probably, you know, address this one first. So we have 3 to the x minus 1 power is equal to 3 to the third power. So I've got the same base on both sides, and we're saying that this is equal. Well, that means that our exponents have to be equal. Right, so that would mean x would have to be 4, right? Add 1 to both sides, we get 4. Okay, well, that's awesome. Let's underline that. And if you go plug that back in there to check yourself, and you should, put in x equal 4 here. We've got 4 minus 1 is 3. 3 to the third power is indeed 27. So we're more confident in that after we have checked it. So long story short here, we're just rewriting both of these terms with all the same base. So let's do this one. We want to pull the same trick, right? So 125, we're not going to mess with that. So 125, we want to write this with a base of 5. I know that 5 times 5 is 25, times another 5 would be 125, so that's 5 to the third. Okay, that's convenient. Now both of these bases are the same, and we can say that their exponents have to be the same, right? Because the exponential function is a one-to-one function, That means that my outputs being the same means the inputs are the same, right? So we can solve this one pretty quickly. A couple more steps involved here, right? We're going to add 1 to both sides first, and then we can divide by 2, and we get 4 over 2 is 2. And we should go back and plug that back in there, and we can verify that it's true, right? If I put a 2 in there, I got 2 times 2 is 4, minus 1 is 3, so 5 to the third would be 125, and that's good. All right, now let's take a look at this one, because this one looks maybe a little more difficult, right? But depending on our comfort level with exponents, this shouldn't be too big of a deal, right? So if I just want to rewrite all these terms with the likely base, which looks like 3 here, so I want to rewrite everything with a 3. Okay, so 9, I know that that's 3 squared. I know that 1 over 9, I can write that as 1 over 3 squared, right? And then this is being raised to the 2x power. All right, so we're just rewriting these things with 3's, right? So our exponents here, we're multiplying the same base and we have different exponents. So we know what we do here, right? We add the exponents. So we got 7x plus 2. And then over here, there's a little bit more work to do, right? So this, we can rewrite that with a base of 3, can't we? 3 to the negative 2, right? That's what negative exponents do. They kick you into the denominator. Okay, so we're not quite there. We have to write just one base here, one exponent. So we want to, combine those. So when we raise a power to a power, we know that we multiply. So that side here didn't change. And then when we raise a power to a power, we multiply. So negative 2 to the 2x would be negative 4x. So 3 to the negative 4x. All right. So now we're in good shape, right? Just to be clear here, because it's a few more steps than the other ones, our goal was to rewrite both sides with the same base, right? So if I have 3 to some power equals 3 to some possibly different power, well, we know that because this is 1 to 1, these can't be different. They have to be the same. So 7x plus 2 has to be negative 4x. So we write that, 7x plus 2 has to be negative 4x. And now we can solve this linear equation pretty quickly, right? We'll just add the 4 to both sides, and we get 11x, and we can subtract the 2 from both sides. We get negative 2. And then we can divide by 11, so negative 2 over 11. And there we go. Now, it would absolutely be in your best interest to plug this in to the original equation and make sure that it makes it true. And, it might be a bit more of a daunting task than the other ones. But, crank it through your calculator and see if we get the same value on both sides. Or, we can absolutely do that by hand as well. Just a little more labor intensive there. So anyway, that's how we solve exponential equations when we can rewrite the terms using all the same base, right? We use 3 here, 5 here, 3 there.